Good afternoon. My name is Tack Kim. I'm from Korea Battery Industry Association. Today, I honor to presentation EV-ESS battery reuse, republication, and recycling technology in South Korea. We started this R&D activity since 2016, and then we are 4 staffs located in the Jeju Island with the Jeju Techno Park to testing the reuse, republication EV-ESS batteries. After that, we are constructed our own facility at Naju province. So right pictures, you can see our process buildings and some reliability and safety buildings. So I will tell you about our details, our experience about the reuse batteries. This is an introduction about the second use batteries. We say this is a second use optimization because the EV car, they are the high performance of the battery characteristics. So the battery lifetime is limited around less than 8%. So the first life came starting from the 100% to the 80%. After that, we can use more lifetime for use less performance application like the energy storage system and other street light. So we are considering to how we can use for the second life battery to our industries. So we said this is first used from the EV cars. After end of the life, then we can use the energy storage system, e-mobility, and street light, and e-shifts. Because there are some benefit to reuse, to recycling, we can reduction the cost of the 30 and 50% of the battery cost. And also the battery cycle life is extended more than 10 years, then we can prevent to the environmental problems. Also recently, the ESS application is much more cheaper than other application, but we are using second use batteries, then cost will be down to 30%, and also the calendar life less than 50%. So approximately it can save the 40% for the cost and everything. And also we have another benefit for environmental friendly. Actually, the battery can be used more like around 5 or 7 years. Then after that, they will go to the recycling. But we believe the for environmental friendly application can use more life, and then they go to the recycling. Also, the low carbon environment societies, they are already finished the carbon footprint in EV cars. So aerosol system, they don't need the more carbon footprint, just need a small size capacity because to assembly. In case of Korea, we are expect to the 8,000 EV batteries can out from the market. After then, we expect more than 200,000 EV car battery will be go to the recycling. So we hope it can be possible to use another application from the 2023 and 2030. This is a global EV battery demonstration. So you can see that many countries can operating the second life battery for another application, like to the street light and large scale power storage and energy storage system and EV chargers and mobility house and energy storage system and backup power elevators, solar energy storage management, EV chargers, and also the data centers. In case of Korea, we are starting to do this R&D activity in 2015. So the Hyundai Mobility, they have some extra battery for after the battery EV cars testing. Then they are using this car who use another application like the energy system. It can, including the 28 kilowatt hours PV packs, can accumulate 218 kilowatt hour for the Hyundai Steers. Also, we have the challenge to use the hybrid system. That means the used battery combined with the new batteries. So we have to design for the EV car from the EV electric bus, and we can combine to the new battery with second use batteries, can supplying for the electricity to the buildings. Another challenge is the EV chargers. So you can see the several EV car battery packs from the I3 Jeju Island. We are accumulating and converting to assembly to the EV charging station. So it can be possible to the charging the EV cars. This is another application of the UPS for the telecom stations. So we have several experience of those since 2017. So Hyundai Cell Energy System, EV chargers, just say substation UPS, energy dream centers, PV station, and we have some small energy system for using various kind of the EV cars. This is our process design of reused battery early publication, 2017. We are starting small energy system and UPS and EV chargers, and then it will be spread out to the more application using the energy EV batteries. So we can expect second life battery application will be go through to the small mobility and stationary system, depend on the battery capacity. We are constructing our new facility in the Naju Island, so Naju province. So you can see that some our process line, it can process around 1,000 EV car battery per year. So I will introduce more detail about the process design and facilities and equipment. Also, after that, we need some reliability and cycle life verification and EMC verification and safety performance testing facility like the reliability, environmental tests, and safety tests for the second use batteries. We are make our own definition about the reuse, republication, and recycling. So this is a full life of the second life battery, end of the EV battery, or end of the energy storage system. After that, after the finished life, first life, then we can test into our battery packs, and then we are grading to classification for like the class A. That means the capacity and SOH is higher than 80%. It can be possible to the reuse, including the EV cars, EV bus, and other things. Also, the less than 80% and higher than 65%, it can possible to the republication using energy storage system and e-mobility and through ride. But finally, the less than 65% of the batteries, it goes through to the recycling. So it just to getting from some materials, lithium and cobalt, cobalt will go to the battery manufacturing. But you know that this whole process will lead to some research activity about how we can testing the packs and modules, how we can design to the BMS, how we can approve the certification for the safety and performance. That is our main activity to researching the second-use batteries. So this is our process design for reuse republications. So after that, after end of the life, the battery can separate from the EV cars. We are registered and we make some RF tags and experience after inspection. We go to the test. That means the OCV, isolate resistance, capacitance, HDC resistance, and cells with charge can be possible to the grading like reuse, republication, and recycling. But the testing sequence will be separated by to the pack and modules, and then we are make some functions to how we can evaluation and verification about the reuse, republication, recyclings. This is our schematic process about the from the warehousing to the factories. So you can see that some warehousing process we are carrying on the battery packs and go through the washing and some appearance test, and then go to the electrical test, and then we'll go to the evaluation for the pack size, and then go through to the disassembly to the module size. And after that, we separate to each modules. We'll go to the residential test and SOC test, and OCV test go to the warehouse. During this test, we are selection to some grade C. That means the rest of the 65% of the capacity, and SOH will go to the recycling. But in this process, we have still more 9.5 hours to evaluation for the battery packs. There are several technology to evaluating the SOH, SOC, SOP for using the charging and discharging, resistance test, and full charge discharging, and half charging, and various kind of the test method will be applied for this evaluation. You can see the more detailed process. We are made our own manual process to warehousing, package inspection, and package electrical inspections. This is our facility to test our pack inside of the chambers. After we are analyzing the test result, like the pack test and module test, and some kind of the data analyzing, and we can to classification about the grading of these EV battery packs. We also have to the economic analyzing to the reuse and recycling. In case of the 2017, we are get the 12 EV battery user batteries, and then we have another source from the hybrid batteries can around 3,600 EV battery pack go out to the EV cars. But you know that the hybrid battery system is just 1 kilowatt hours. That means the 3 megawatt hours battery packs go out from the hybrid cars. Also, the 12 EV user battery, it had around 300 kilowatt battery packs. But 2020, we have to 1,400 EV car batteries go out from the EV cars. Also, the 19,000 hybrid battery cars go out through the hybrid cars. That means is to the 90 megawatt hours battery pack from the hybrid car and 300 megawatt hours battery pack from the EV cars. Actually, people I mentioned about the size and capacity will be go increase more than more people. This is our current state of the end of the life battery packs. The recycling will go to we'll just to get the lithium and cobalt, some manganese and other things. But the second life, there are inside, besides before the recycling, we can reuse republication around 5 or 10 years for energy systems to right is calculating to the adapting to the energy storage system price around the 250 US dollar per kilowatt hours. That means that 91 million US dollar per US dollar can get benefit from the second life. Also, we spend more process cost and some other things, but we can make the profit using the extra profit economic benefit from the second life. After that, it's same tons and same price of the recycling. I introduced our recycling industry in Korea before in 2015. I calculating our recycling industry supply chain. So almost supply chain and produced by sourced from the domestic 1.4 ton, 1.4 tons, and we can uh, import it from the overseas. This is around the 1.3 tons, and just extra came from the 1.7 tons. Then go to the material disassembling, crushing, and hydrometallizing. It can producing to the some previous materials like the cobalt sulfate, nickel metals. Then we can go to the some using for the energy battery industries. Also, the current process is just simple to the collection, physical treatment, and chemical separation and purification. And after that, we can use the metallization. So lithium battery go to the raw materials. This is our some photo to the current process of the waste battery or lithium polymer battery goes through to the some raw flask of discharging, dehydration, drying, crushing, and magnetic separation, screening, dust collection can go through the some metals. Also, we are other application about to the hydrolyzing, wrenching, filtering, and then solvent tank and solvent extraction, crystallizing. Then you can get some previous materials for the lithium batteries. But we are thinking to the another new clean recycling plant. So before I mentioned about our facility will use to reuse for the grade A and B, and grade C will go to the recycling. But recently, the U.S. government supporting to the clean recycling technology. So resale, they are just collecting the active material from the electrode. Then it can go to the republication by cathode materials. Also, we are planning to another facility in the Gwangyang areas. We are starting this project in this year. So electrochemical recycling processor will be developing this facility. That means just disassembling cells, and then we separating the electrolyte, current collectors, and cathode materials. After that, we need some metal collection process to separating to the lithium, cobalt, nickel, mangan, and graphite. And then also we can get some oxidation materials. After that, we are physical evaluation. So they don't need any metallizing treatment and other things. Just simple process to get the raw material can be possible to the republication by cathode materials and anode materials. So in our business model, we'll go to like this one to Jeju Island, and Naju will send to the end of life battery go to the Gwangyang, and we will make this process more clean technology to use the recycling. I hope this reuse, republication, recycling will help to the clean environment to use to expand our lithium battery technology. Also, we hope to see you. I hope to introduce more detailed, real-time processing to the reuse republication in next years, because our facility will complete the construction in next February, and then we will process the more than 1,000 EV battery packs to use the republication use in end of the next year. Thank you.